Hello, this is Mr. Stein, and in this video we're going to look at the Chapter 7 unit in graphs. So we're going to look at what happens when we have a trigonometric function that we're going to graph. So we are going to graph this function right here, y equals sine x. Right, we're going to need a calculator open for this. And there are two ways to measure angles. Well, there's 3 or 4 ways to measure angles. We are working with degrees. That's what we normally work with. On calculators, you also have radians. We don't want to work with radians. We want to make sure that we're working with degrees. So in order to check that, we calculate sine of 30. So sine of 30 right there. Let's calculate that first. If that gives us 0.5, we know that our calculator is in degree mode. So I type in 30 sine and I get 0.5. That's perfect. Now we can just go through and calculate the rest of these values. So sine of 0, 0, and then sine, and that is 0. Negative 30, sine, negative 0.5. Negative 60, negative 0.87. Now we only need to go to 2 decimal places. It gives you more, but we only need to go to 2. Let's do negative 90. Negative 1. Let's do 60. 0.87. What do you think 90 will be? Plus 1 instead of negative 1. Now 120. 0.87. Interesting here. If we look at the pattern, you'll notice that we started at 0, got larger and larger and larger, then it got to this highest point right here. This is the highest point, and then it started going down again. All right, let's graph that. Graph this on the grid to the right. All right, so we need some scales. Okay, first thing, we need x scales. So we're going up by 30s. So I'm going to put 3 squares. Every 3 squares is 30. So there's 30, 60, 90, 120, 150, 180. Yeah, that's okay, I think. Negative 30, negative 60, negative 90. We could do negative 120, negative 150, and negative 180. All right, now we need a vertical scale. The highest number we need to go up to is 1, and the lowest number we need to go up to is negative 1. So I don't want to go up too high to make this like really hard to work with, but I want to go up high enough so that I can see like 0.867. So how about we go up by 0.2 each time. 0.2, 0.4, 0.6, 0.8, 1. There's plus 1 right there. Negative 0.2, 0.4, 0.6, 0.8, negative 1. Goes right there. Okay, so now we have a decent scale. Now let's put on our points. At 0, the graph is 0, right there. At 30, the graph is plus 1. At 60, the graph is 0.867. So this line right here is 0.8, so it's going to be just up here. 90, it's 1. Then it's going to be back down at 120 back there. Now, where do you think it's going to go at 150? Well, if you guess 0.5 again, you would be correct. And at 180, it's going to go back down to there. So this is the right-hand side of our graph. Makes this nice, smooth curve. And the graph continues down. Now, at negative 30, it was negative 0.5. At negative 60, it was negative 0.867. At negative 90, it was there. Now, where do you think it was going to go at negative 120? Well, back here to negative 0.867. Then back to negative 0.5, then back to 0. It's going to make this smooth curve here. And there's our graph of y equals sine x. Remember, the real point of this is that you should be able to take any function, build a table of values for it, and graph it. All right. Is there a pattern that you can easily detect from this graph? Well, there is. It waves. It goes down, then up, then down. And guess what it's going to do next? It's going to go up, then down, then down, then up. And it's going to keep waving on like this forever and ever. In fact, we can easily see that in Desmos. Let's go take a quick look at Desmos. Okay, I'm going to type in here y equals sine x. You can see the wavy pattern. Except you should notice something weird here with Desmos. Look at our scale on our horizontal axes. It doesn't match up at all. Why not? Well, that's because Desmos is computing sine in radians and not in degrees. To change that, I go to my mode and I look for my degrees button. See my degrees button at the bottom. I change it to degrees. Now things changed a lot. It doesn't look like it goes up and down anymore, at least not in this horizontal scale. So I can pinch to zoom just my horizontal scale. And now you can see that the scales kind of match up, don't they? You can see this point here, it's at 90, 1. When we go back here, we can see that we have this point right here at 90 and 1. Okay. Let's write the domain and range for the graph. So the domain is all the possible x values. I want to see the graph. I'm going to write the domain right here. The domain is how far left and right the graph goes. How far left and right it will keep going. This graph will keep on going forever left and right. Every x value can fit into it. So it's all the values of x such that x could be any real number. That's our domain. The range is the up and down values. So it's only between these two values. It only goes from +1 to -1. It never goes higher than +1, and it never goes lower than -1. It keeps cycling between the two. So our range, it's our y value, such that our smallest is -1, and it can be -1, and it goes up to +1, and y is any element of the real number. So there we have our domain and our range for this trig function. Remember, the point of this is not to understand the trig function so much, but it's to be able to take a function, put in some values, make a table of values, and graph it. Then you should be able to identify the domain and the range.